My name is John and this is my SquareBot Lab report. The objective of this is to make a robot that would be able to navigate a maze, firstly by timers, by adjusting the speed so it goes the direction and speed you want, and then by using a trigger mechanism like a switch that would be able to have the bot self-navigate by itself without any input from anything else. We had to set up LCD code that would allow us to use our LCD display the status of the bot, whether it's going backward or forward or turning. The next part we had to worry about was the actual gearing, and I chose 60 to 36 teeth gearing. So the way it is, it goes from the shaft of the motor to the 60 tooth gear to down to 36 on the axles. Another problem that I encountered at the very beginning is the instruction kit that had it set up, put the robot together, it said we could use a clutch. Later on, when I was actually running the thing, the robot would slip on one side or the other, and I went back in, I took it apart and I looked at it, and the clutch was actually slipping since you're using plastic on metal, so I had to take it all apart. You'll see in these next slides code set up for the LCD to work properly, and also I'll have loop codes set up for, well, obviously void setup in pin mode, and over here the way the loop goes on the timer, and you see forward and stop. You see over here each section of code when you run forward or reverse has its own separate code. So if it does forward, display this; if it does back, display this, etc. Again, this is the code in operation on the LCD, and this is during the timing part, objective 1. I couldn't get the camera to go on the bot itself, but this is the way it would work. Whenever it displays something, that's what is happening to the wheels. So this is the video of the timer, objective 1, so navigating the maze with timers, and that was what you saw before, where it says forward, stop, turn left, stop, and that's the way it's ran through here. Having the code set up beforehand, where it says define all these variables first, it made it a lot easier to analyze the code and to do troubleshooting later on. Now this video shows some problems encountered with using the actual sensors. The sensors worked fine. I should have increased the turn radius so it'll get past the block. Also, another thing is the fact that the front axle wheels are further out than the sensors, so there's a dead zone after the end of the sensor and the wheel, so it gets caught every time I try to run it. A solution would have been to increase the surface area, well, essentially increase where the sensor would be over the axle. This is another attempt getting up that ramp. You see the issue there, the wheel catches it and it slides into the wall. Previously, when we had the setup with their bot, we had smaller wheels and they were closer together, but they were smaller diameter, and I've seen other students in the class try to use it, and it wouldn't go up the ramp. With the gearing that's set up, it wouldn't go up the ramp at all. Also, right here, the way the profile, the height of the bot could get caught on the toolbox, and again, with the way the wheels are set up, or they're not, the sensor coverage doesn't go over the wheel, so that's an issue there. In the end, I would have increased where the sensor would be so it covers the wheel, and I would have increased the turn radius on each of the turn triggers.